the air temperature above coastal areas is profoundly influenced by the large specific heat capacity of water. How large of a volume of air can be cooled by 1 degree Celsius if energy is transferred as heat from the air to the water, thus increasing the temperature of 1 kilogram of water by 1 degree Celsius? Alright, so let's look at the givens first. How large of a volume of air can be cooled by 1 degree Celsius? Now, this means that the volume of air, the air is going to be cooled and the water is going to be heated. So the heat lost by the air is equal to the heat gained by the water. So we write the mass of the air, specific heat capacity for air, plus or minus, change in temperature, is equal to the mass of the water, specific heat capacity for water, plus or minus, change in temperature. Alright, we're given the air is cooled by 1 degree Celsius. So the change in temperature for air is 1 degree Celsius. We're increasing the temperature of 1 kilogram of water, so the mass of the water given is equal to 1 kilogram, is being changed by a temperature of 1 degree Celsius. So the change in temperature for the water is 1 degree Celsius. Now, we don't have the mass of the air, but we know that we can look up the density of air. The density of air is equal to the mass of the air divided by the volume. And so the mass of the air is going to be density times volume. So let me just write this. The density of the air times the volume of the air is equal to mass. So I'm going to make that substitution now. Density of air times the volume of air. Now the specific heat capacity for air. If we look this up, you'll find that the specific heat capacity for air is 1,000 joules per kilogram Celsius. Now the change in temperature is 1. So we'll just write 1 here. The mass of water is 1 kilogram. The specific heat capacity for water is 4186. And the change in temperature for water is 1. Now, we have all the numbers for everything except for density of air and the volume of air. And we can look up the density of air. That's 1.29 kilograms per cubic meter. So this is going to be the volume of the air is going to be equal to 4186 divided by air is 1.29, and that's 1,000. So we just punch this in, and that will give us the volume of the air. 4186. That gives us 3.2 cubic meters. That's it.